Okay, in this section we're going to look at the quadratic formula and how it helps us to solve quadratic equations, particularly when we are unable to factorise. So if we have a look at the general form of a quadratic, that is ax squared plus bx plus c is equal to 0, then the quadratic formula, which solves the quadratic, it does use a technique of completing the square. If we were to complete the square, use the technique of completing the square on this quadratic, we would, after 7 or 8 steps, arrive at this result. And this is the simplified version of the outcome. So x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. That is known as a quadratic formula, and it is most useful for finding the solutions to quadratic equations, as I said, when factorising is not an option. So if we have a look at an example, then let's have a look at an example where factorising will not be an option. Solve this quadratic, 4x squared minus 3x minus 2 equals 0. Okay, so at the outset we look at this and try and factorise it. That's always the best method. In this case we're looking for two numbers that will do this: multiply to minus 8 and add to minus 3. Pairs that multiply to minus 8, 8, 1, so we're not going to get 3 out of that, 4, 2, we're not going to get 3 out of that. So we arrive fairly quickly at the conclusion that this is not factorisable, so we're going to use the quadratic formula to solve this for us. So how do we do that? Well, it's just a matter of identifying a's, b's and c's. So that's our a, so a is equal to 4. This here is our b, the coefficient of x is our b, and that's minus 3. The sign is obviously of crucial importance, and c is minus 2. So let's now go ahead and use the formula that helps to solve this equation for us. So x equals, let's go for it now, we've got minus b, and b is already negative, so that's actually going to turn out to be plus 3 when we on the next step when we simplify. And b squared, well, this b is minus 3, so we square that, minus 4ac. Now I just like to use brackets here to signify multiplication. We need to be careful with that we get all that correct. And underneath here we've got 2 times 4. So if we work this through now, minus 3, as I said a minute ago, that's plus 3. Plus or minus the square root of minus 3 squared, well, that's 9. Minus 4 times 4 is 16, times minus 2 is minus 32. So that's going to turn into 9 plus 32 when we next simplify. So I think what we'll arrive at now is our simplified 9 plus 32 is 41 over 8. So there are two solutions to this quadratic: 9 plus square root of 41 over 8, and, sorry, 3 plus square root of 41 over 8, and 3 minus the square root of 41 over 8. Two solutions solving a quadratic equation. Now this is going to be of use firstly just to find the values of x, as we've done there, but if we were looking to graph the equation, if we were looking to if the task was to graph y equals 4x squared minus 3x minus 2, then we could use these values here as our x-intercepts, because this is the solution to 4x squared minus 3x minus 2 equals 0, and as we know, when y is 0, we're on the x-axis. So we could go ahead and graph this now using plotting these as the x, these 2 points here as the x-intercepts, and we could also find the vertex from a's, b's and c's. Our vertex is at minus b over 2a. Now let's just write that down. So we have x-intercepts 3 plus root 41 over 8 and 3 minus root 41 over 8. Now if we think about the approximate value of those, we'll do that in a moment, but that's about 9 over 8, just a little bit more than 1, and this is 3 minus, this is about negative, just a little bit less than negative a half. But we can also find our vertex, or our turning point, which is at x equals minus b over 2a. Now in our quadratic, minus b over 2a is minus 3 over 2 times 4. So in our case, that's going to be minus 3 over 2 times 4. So that's 3 over 8. That's our vertex, our x coordinate of our vertex. Okay, so the last task now is to graph the quadratic, graph the parabola. There we go. Get ourselves a little, oh dear. Let's try that again. Trying to activate the XY plane. Okay, and now to sketch this out, we will look at our x-intercepts. And so this is just a bit more than 1, this is a bit less than 1.5, so and the y-intercept is always at x equals 0, so in this case it's minus 2. So the y-intercept is at minus 2, perhaps just make a note of that as well. Y-intercept is at minus 2. So let's put all this information down now, not to scale. I'm calling that minus 2. I'm coming through there, I'm dipping. I know it's a concave up parabola because it's a positive x squared. This is at minus 2. This point here is 3 minus root 41 over 8. I'm just leaving that in exact form at the moment. This point is 3 plus root 41 over 8. Now the vertex here has x coordinate of 3/8. Remember we found that by minus b over 2a, and if we substitute 3/8 into the equation of the quadratic, back into the quadratic equation, you'll have to trust me on this, but if you work it through, you get minus 41 over 16. That is the result of calculating, putting 3/8 back in here for x. So 4 times 3/8 squared minus 3 times 3/8 minus 2 goes into your calculator, and you'll get that to be your vertex. So that's how to use the quadratic formula to solve a quadratic, and in doing so also find the roots of the parabola, the x-intercepts of the parabola, this being the x-axis, when you look to graph a quadratic which doesn't factorize. So you're unable to factorize and find x-intercepts that way. The vertex, x equals minus b over 2a. So worth taking some notes down on that, and then we can do some exercises in class in the next lesson.